Welcome everyone to today's webinar, Kubernetes attack, anatomy of the Shopify attack and how to defend your infrastructure. With our speaker today, Garwood Pang. He's a security researcher at Tigera. He has around 3 years previously with GE Digital as a vulnerability researcher for the industrial control systems, and around 3 years at Fortinet where he was protecting IT networks. And so that gives him the experience to talk about this subject today. So without further ado, I will hand it over to our speaker, Garwood.
Hi, thank you, Michael. Glad to be here. So what are we doing today? We will walk through a possible attack scenario that I've made based on high-profile breaches, bug reports, and blog posts. We will look at each stage of the attack, and then we can see the different ways we can mitigate or prevent it from happening again. We will also try to see why a zero trust approach would benefit in this situation. So from looking at the several high-profile attacks and breaches, the most common attack vector is via something called a server-side request forgery attack, also known as a SSRF. From here, the attacker can leverage the SSRF to access the internal APIs, cloud resources that is connected to the instance, and the cloud provider's metadata service. With the access to the access to the metadata service, the attacker can then retrieve the cloud identity and access management role credential. And then finally, with the stolen credentials, the attacker can then impersonate the resources and then gain access to the Kubernetes cluster. So what is a server-side request forgery attack? It is abusing the functionality of the server to read or update internal resources. Usually it involves modifying a URL or a form, which then the server will then process and then make a request on your behalf. This might sound a little bit confusing right now, but once I show you in the demo, it should make more sense. The metadata service is used by the cloud operations to retrieve info about the running instance. It usually provides like hostname, IP address, the IAM role credentials, and other useful data to help manage and scale instances. And to access the metadata service, it's actually quite simple. You just have to query from within your instance. The 169.254.169 IP address for both AWS and GCP, or the domain metadata.google.internal for GCP. In Kubernetes, the interesting part here is that actually every single pod actually has access to this metadata service by default. This is because, for example, on GKE, Google's managed Kubernetes service, it's actually still running on GCP. And in every instance in GCP, you have to access, you are able to access the metadata service. This is also the same for AWS and their EKS offering, because EKS is also running on EC2, and then EC2 has their own metadata service. It is also important to note that the operator of your cluster or your cloud, you can also add like your own custom attributes and data into the metadata service. The cloud identity and access management service is another service that is provided by the cloud providers. The IAM service manages access to cloud services and resources by mapping role and group access and deny permissions to different cloud providers' offerings. This means that you can actually create new GCP or like EC2 instance. You can assign a role to an instance with those specific permissions. The instance can then like access those other cloud resources. So you can have your EC2 instance to talk to S3 buckets, load balancers, or even other EC2 and compute engine itself. Once you have the credentials, you can actually grab these credentials using the metadata service, and then someone can reuse these credentials. But the issues for this is that this credential is actually rotated really frequently, so that you can't really just keep it. Unlike how you can do it with what usually some people do is they just store like the or AWS access key into your instance, or like using it as like an environment variable. This is actually, yeah, as I said before, it's better than using just AWS keys or storing in your environment variables, because you can actually actively revoke or change or log all the permissions on the fly. So our setup today is basically a very basic GKE cluster. We're going to run on GKE 1.14.7. I have enabled the legacy endpoint for this demo, and I've also enabled the internal visibility settings. We're going to install Tiger Secure 2.5.1, and we're going to use Calico as the CNI. And other than that, everything is pretty default. So in our demo, we're going to have 3 pods with 3 surfaces. We have something called a shop app, a view app, and a screenshot app. They are all placed in the default namespace. There's no network policy applied at the moment, and everything is accessible by everything else. So all the pods can talk to the internet, they can talk to each other, and anything else. So let's take a quick look and see what our shop app actually looks like. So here's my shop app. It's like very, very basic, as you can see, that we can use to look at and see what it is, right? So what we can do here is that we can go to the different stores that I've already created. So we go to like store A, we can see, oh, we have like selling A stuff, very basic, same as B. So now we have this little form where we can actually add our own store. So we can try that out. So let's try creating a store named C, and we're going to sell C stuff. And then once you click submit, it just shows you the new page that you have created, or the new shop that you have created. Now that we know this, we can now start to play around with what we can poke around and see what kind of issues this shop actually has. So the first thing I'm going to do is just open on my terminal the next command that we're going to use. So the first thing we're going to check is to see if there's any sanitization involved in this this form. So the most basic thing you can always do is just copy and paste, or try to add in a HTML header, or sorry, like a H1 header. This will then tell us to see if they are sanitizing anything, or if we actually process the H1 header. And once I submit it, we can see it gets bold, and we can see that, oh, this site is actually pretty vulnerable. We can actually add in our own HTML headers, or sorry, HTML tags into this website. So now that we know this, we want to look further, right? Having just HTML tags doesn't do much. You can only play with like kind of like themes and stuff. The next step we will always want to do is try to look at to see if we can include JavaScript. And the second one we're going to try is just a very basic like cross-site scripting script. And with this script, if it works, that means that we have a cross-site scripting vulnerability in our site, which is not a good idea. So I'll just paste it into our content, and then we click submit. And hey, we can see that we have the prompt pops up and it says hi. So now we know, okay, this site it will also basically accept JavaScript, and it will actually reflect back to us. Now, having a cross-site scripting is not very useful because everything just reflects back to your browser. We want to look and see if there's anything else. The first thing we're going to try is to try to do a redirect. And here, this is my script. We're just going to do Windows location, and then we're going to redirect to Google, right? So let's see if this works. And then I click submit, and you can see it briefly loads the shop F page, and then once it hits the JavaScript, it instantly redirects us to Google. So now that we know that we can actually start doing some redirections. This is by itself pretty useless because, for example, it's actually kind of dangerous because For example, you can put a redirect to like a malicious web page. So then if someone comes to your shop, they will get redirected to the malicious web page, and then they may get hacked. So let's head back to the slide for now, and let's review what we just did. So what happened? The shop app does not do any sanitization of the inputs. We can add HTML tags as well as embed JavaScript into our shop page. Since the payload only gets reflected back to the user, we only have essentially client-side related attacks only. In the demo, I actually show you how you can put in like a basic cross-site scripting attack and then a redirect. Now let's take a look at the View app. So this is not the second site. Similar to before, it's very, very basic. All it has is we can add a new site to our list of sites for sale, and we will then see it on our bottom part. So we can try and add a new site, right? So we're going to add back our original site A. And when I click submit, what happens is that the View app will talk to the screenshot app, which will then go to our site A and then take a picture of it, or shop A, sorry, and take a picture of it. And so here we can see, it takes a picture of our site A, so that's pretty interesting. We're going to go to our site B, and then the bot will come and take a picture of the site B. So now that we have this thing, which is kind of interesting, we might be like, hey, let's see if the redirection works, right? And if I remember correctly, our redirection site is site F. And when I click submit, hey, look, interesting, right? So what happens is that the bot is, when the screenshot app goes to our site F, it will start parsing the HTML response. And then once it hits the JavaScript, it will be like, oh, I need to redirect to Google. So then I redirect to Google. So now we know that the screenshot app actually follows the redirect, and now we can do more interesting stuff with it. Before we go further out, we can also think about how, since we know that we can kind of control where the screenshot app goes, why don't we just go to, like, for example, Google, right? So we can change this to www.google.com. And then when we submit it, it will actually block us from using this to access external URLs. So we can really just, instead of skipping the shop app, just get the screenshot app to go and grab Google instead. So there's some sort of like mitigations to prevent you from like accessing remote resources. So back to the slides. So let's review what happened. The View app sends a request to the screenshot app to take a screenshot of the target's front page. The View app can only access internal websites. And since we can control where the screenshot app goes via the shop redirect, our originally client-side attack becomes an SSRF. So now that we have this, we can go to the next step. So according to, as I said before, a lot of recent breaches and reports, people like to go straight for the metadata service because it has a lot of useful information in it. So we're gonna try to do that too. Yeah, so we're gonna, on our right on the terminal, we can see that the script that we're gonna run next is we're going to redirect to the metadata service. We can see it's just the same thing as the redirect that we did to Google, but instead we're going to go to the metadata.google.internal, compute metadata, B1, and we're going to try to hit the service account called service account default token. So now we're going to go back to our site where we're going to have our store called store G, and then the store is going to redirect to the metadata service. And when I click submit, we can see that we went to the site G store very briefly, and then once it hit the metadata service, it would then show us this 404 page. The reason why it's 404 is because on my laptop, there's no such thing as the metadata service because I am not on the GCP infrastructure or network. So hitting the site on my laptop will not do anything. So yeah. So, but when we go to the our view app, where it will tell the screenshot app to go to the store, we will actually see. I will go again. So we can see that when the when the screenshot app goes to this page, we actually see something else that's different than what we just saw, right? We see that there's actually this Google reply saying that we have a full free error. And it's telling us that your client does not have permissions to access this URL because we're missing this metadata flavor.google header. This is what Google has done to prevent this kind of attacks. A lot of times when you have a SSRF, you do not have like header control. So when you have this header, it kind of blocks this kind of attack from happening. But another way to bypass this is to just use the previous version of this API. We can see here on the right, instead of having it in the compute metadata version 1, we can go back to the version 1 beta 1. And what this does is that back then when they had this version 1 beta 1, they actually didn't require this special header, and it will work. So let's go to site H. We're going to create a new store called site H. We're going to replace our previous commands to the new one. And we can see what happens. And when I click submit, of course, when it redirects, we are not going to reach anywhere because we're not part of the network. But since our screenshot and view app is, we can use our app. And when we click submit, the screenshot app would then follow the redirect, goes to the metadata service, goes to the version 1 beta 1 endpoint or the API, and then is able to access the data. And here you can see we have the access token, YA, blah, 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 and then we have this. So with that, the attacker then has gained control of and retrieved the cloud identity and access management role credentials token. So heading back to the slides, we can briefly go over what we just did. Oh, sorry about that. We're actually going to continue on. So let's head back. So now that we have this token, what we can do now is just to look around to see what other interesting stuff we have inside this metadata service. And to do this, I am just going to use play my commands that I've done before. So we're going to do the first part, and we're just going to look around. So the first thing we're going to look at is just the metadata service of itself. The way I'm going to do this is I'm just going to actually use kubectl and exec into my screenshot app, and then we're just going to curl to the metadata service instead of using our website where we're going to have to create a store, then set a store on sale, and then look at it and wait for the reply. We're just going to directly hit the endpoint and see what it is. So here we can see when we just hit the metadata service. Let me just quickly check. Yeah, when we hit the API, the V1 beta 1, we have these 3 different folders. From there, we can actually get the project name of the cluster. So we can see we're at Tigera Secure Research, which is a special project that we have made for this demo. Next, we're going to just list out all the instance contents that we can find, or just within the metadata service. And when we hit it, we can see there's a lot of very interesting stuff, right? Like attributes, description, host name, network interfaces. All these are all available for you to use when you want to access the metadata service. The first one we're going to look at is the host name. So then we can roughly see like where are we once we got into the cluster. We're in GKE, my Garwood demo. Then next, we're going to look at the network config. So once we hit the network config, we can see there's some very interesting stuff, right? Like the external IP. This is the external IP of the node that's running the screenshot app. So now we kind of know roughly the IP address, or we know the IP address of the screenshot app's node. So we kind of know, and we can ping, or we can like start doing more stuff and try to access this node. We're gonna grab the service account token, what we did before. But instead now we're on the command line, so we can actually later on parse out the stuff that we want. And here you can see, right, we actually get the same reply as the one on the left. We can see it's like the token is actually different. If you look at the last few digits, it's actually like 1EXF, whereas here is 8UFO. This is because, as I said before, these credentials roles rotate really quickly to kind of prevent people from just finding this token, grabbing this token and then keeping it and then reusing it like forever. They rotate it quickly, so then you have to continuously like grab this token to then do malicious stuff with it. So now that we have the token and the project name, what we can do now is to see what kind of permissions we have. First, what we're going to do is we're going to grab the token again and the project ID. So we're going to do the same thing where we're just going to exec into the pod and then do a curl, but this time with a bit more scripting at the end to basically pull out the relevant part that we want. So first, yeah, we got the token, and now we're going to grab the project. So now that we have the two, we can now talk to the Google's own API, where you can use it to check out what kind of permissions that we have for this token that we just found. So here we can see after we hit the Google API's endpoint, it tells us that our scope is only here. Our scope is only the user info.email and the cloud platform. If this credential if it has more permissions, you would see like compute engine or storage. And with those permissions is when you can actually use this credentials to like spin up more instances, or you can like access all the storage buckets and then take a look at those. But unfortunately for us, this token doesn't have much. So as I said before, you can always put in data into the metadata service if you have the permissions. So here, this is a command that will post into the Google APIs and then try to inject some basic like test value into it. The reason why you do this is because some people would like to basically put in their SSH key into their instance, so then they can do passwordless login to the SSH. But from here, we can see that we actually have no permissions. Everything is getting forbidden. So we can see that this token is pretty useless. With that in mind, we're just now going to continue and look around, because the token we found is not very useful. We need to look around and see what else we can get. Here, I'm just going to hit the instance attribute part, and we can see where there's a lot more very interesting information, like the cluster location, the cluster name, and at the bottom, there's a very interesting file called kubeenv, kubelabels, and kubelateconfig. So, of course, we're going to go and look into it. So first, we're going to look at the kubelabel, which doesn't have much information in it. So all three of these files are basically what GKE is used by GKE to spin up the nodes And then once the node is spun up, these are the credentials and files, config files that they need to then talk to the master node to join the cluster. So here, this is the kubelet config, which is, as I said, the configuration file. There's a lot of interesting stuff that you can use, like there's the memory stuff that you can look at, CPUs. And lastly, the kubeenv file is the most important file that we can find. So you can see, right, there's a lot of information that just spelled out on my terminal. So scrolling it back up, we can see there's a lot of very interesting parts. First thing is the CA cert, the certificate authority certificate. We can see our cluster name. We can scroll down, and then we can see the kubelet certificate, and then the kubelet key. And then another big thing we want to know is that there's the Kubernetes master name, which is the IP address of the master node. So with that in mind, we now have enough information to talk to the Kubernetes API server. We're going to head back to the slides, and we're going to review what we just did. So we queried the metadata service, but it was blocked by Google's mitigation. This is because the current implementation of the API requires the metadata flavor.google header to be part of the request or it will be blocked. Luckily, in our case, the old metadata API is also available, which doesn't need the special header. With that, we were able to access the metadata service. Google has since disabled this old API, and by default, that's why I had to manually enable it. And this old metadata service API will eventually get removed. We were able to then grab the token using this API, but from looking at the permissions, we can see that it was pretty useless. If there were more permissions, as I said before, the attacker can then list all the buckets and then sync them elsewhere, or they can just provision new instances and then install crypto miners, for example. You can actually even, if there's permissions, you can actually give yourself more roles or more permissions and grant yourself more privileged access. So after that, we continue to look around and we found several interesting Kubernetes-related files. We found the kubelet config and the kubelet env file, and within the env file, we got the kubelet credentials and the IP address of our master node, and as well as the Kubernetes API server. So now we're going to see what we can do with the credentials that we just got. So the first thing we're going to do is we're going to pull the different sections we want of the kubeenv file. And the three main parts that we want is the kubelet certificate, the kubelet key, and the certificate authority certificate. And to do this, it's just the same thing as before. We're just going to curl into the metadata service, do some scripting to pull the different sections out, and then do a base64 decode because by default, Kubernetes, the kubeenv file store everything in base64. So I can see it on the top right, this is base64. Next, we're going to actually take a look at the files and see what they look like, right? And you can see the first one is the certificate authority certificate, the RSA private key, which is the kubelet key, and then lastly is the kubelet certificate. So with that, we also want to grab the cluster master IP address so that we know where to talk to or who to talk to. And now that we have all three of these data, what we can do is now try to log into or talk to the Kubernetes API server. But first, we're going to have to remove my current credentials that I'm using because the current credential has admin and that doesn't we're not supposed to have that. So I'm just going to remove my kubeconfig, so then we can no longer talk to it properly. So if I do a kubelet get pods, you can see that we're getting the standard, like, there's nothing to connect error. So now we know, okay, we don't have the credential anymore. And then now we can do the kubectl, and now we can put in our new set of credentials. And to do this, you just have to put in the specific flag. So for example, client certificate is the kubelet certificate, the client key is the kubelet key, and then the certificate of authority is the CA cert, or the certificate authority certificate. And then when we try to get pod, we can see that we actually get an error. But you can see this error is different than the one we saw. This one actually tells us that we are forbidden from accessing the pod resources because our user is kubelet. So what happened is that here, Google has now since fixed this credentials that we can grab from the metadata service. It can no longer have much permissions, and that's why we have no longer have interesting permissions on it. So heading back to the slides, we can do a quick review of what just happened. We parsed out the 4 different parameters we need: the master node IP address, the kubelet key, the kubelet certificate, and the certificate authority certificate. This then allows us to talk to the Kubernetes API server remotely. And previously, these credentials let us exec into the pods and then do more, but Google has since reduced the permissions. The credentials that we now have is something now used for something called TLS bootstrapping. In a future webinar, I can show you what we can do with these credentials. But for now, we're just going to review what happened, right? So originally, we have the shop app which we can find is vulnerable to client-side JavaScript injection. We were able to inject HTML tags, cross-site scripting, and redirects. Then we look at the view app, and we realize that the screenshot app goes and takes a screen capture of our shops. It will actually process the JavaScript and follow redirects. This means that we now have an SSRF within our screenshot app. And with that, we can then use the SSRF to reach the internal service, such as the Metadata Service. And then we found several interesting attributes within the instance, such as the instance token, the project ID, and then the kubelet config, and then the kubeenv file. And within the kubeenv file, we were able to retrieve the kubelet key, kubelet certificate, and certificate authority certificate, and then the Kubernetes master IP node, Kubernetes master node IP address. Using this information, we can then talk to the Kubernetes API directly. Luckily or unluckily for me, the credential we stole, none of them was actually useful. So now we should take a look and see what we can actually do at each stage of the attack. So for the SSRF, this type of vulnerability is actually quite hard to detect, as it usually is a implementation or a design flaw of your application logic. It is only when it is exploited or there's the vulnerability is found that you can create like an IID as an IP signature. But when that happens, usually you should just fix your application logic. In our case, the shop app should sanitize the inputs from each HTTP request. We should filter out all the HTML or JavaScript related tags using libraries or built-in escape functions. Like many web applications now, like PHP or Node.js, you can just like import a module and it does everything for you. But sometimes fixing it might be hard, right? What if you want the users to be able to have their own custom CSS or JavaScript on the storefront? This approach would, what we want to do then is we want to provide them with templates or host the CSS or JavaScript for them, and then maybe do some checks to see if they're doing anything suspicious. We should never like be like how my website was, where you can just do anything you want. Another thing we can do is we can use network policies to reduce the attack surface. There's actually different ways we can restrict the communication between the pods. For the screenshot app, we can have 3 different ideas. We can make it so that the screenshot app can only talk to the shop app. This will mean that if our shop app have images that's stored elsewhere, it will not able to reach it just by using this policy. We will then have to add another separate policy to allow it to talk to the storage server or something like that. The second thing we can do is just block egress to the external resources. This would prevent the screenshot app from redirecting to Google, for example, or the metadata service, since they're technically outside. But then this will also have a similar issue as before, where if the shop has like have some sort of CSS or JavaScript that's located elsewhere, it won't be able to reach it. Lastly, what we can do is we can just block the metadata service. And this is just by blocking for example, the IP address 169.254.169 or metadata google.internal. For the view app, I showed you that the view app actually blocks external URLs, if you remember. This was actually done by the application logic only. This means that if the pod gets compromised, the attacker can still reach the internet or other pods. Since there's no network policies or anything used to prevent it from happening, other than the application logic. So in order to have defense in depth, we actually should add a network policies to the view app to block egress to external resources. The recommended way is to introduce network policies to start. And we're going to do a default deny all first, and then slowly enable the different policies so that the pods can talk to each other until it works. This is like the least privileged model you want to follow. For the metadata API, we want to make sure that the legacy endpoint is disabled. Unfortunately for AWS, there's actually no special headers, so you might have to look deeper and see what other ways you can prevent this kind of attacks. On GKE, on GKE, very recently, I think they're gonna permanently remove this legacy endpoint. I actually got an email like the other day while setting up this demo from Google telling me that this is gonna get removed. So soon it's gonna be permanently removed, so you'll be fine. We also want to set the token to a minimal permissions like what we just had in this demo. On GKE, this is the service account. Using metadata concealment on GKE would also be recommended. What this does is it hides the sensitive information, for example, the kubeenv file. And the way they do it is just having like kind of like a proxy between the metadata service and your cluster, and it will just filter out anything that is sensitive. It is also recommended to use the workflow identity for Google and kube2im or KIM for AWS. These allow like a finer gain control of letting you set individual or group permissions of cloud resources within your Kubernetes cluster. This means that you can actually set specific pods and give them certain access to certain resources like storage buckets. Because, for example, right now, the token we set, it basically applies to the whole cluster. Whereas if you use this kind of stuff, it shrinks your permissions into individual pods or individual services to have like certain permissions. For the kube cuddle part of the attack, where I pull out the different data and then log in or try to access the Kubernetes API server, it really depends on what kind of credentials the attacker was able to get, right? If they were able to grab the admin credentials, for example, then they have full control using kubectl, and you can't really do anything about it. But in our case, the attacker or me didn't grab the credentials that was pretty useless. So what we want to do is we want to audit the role-based access controls. We want to make sure the name spacing between the pods and servers are correct. And we want to check all our role bindings for our service account, especially the Bootstrap account. We also don't want to have our API server available to the internet. By default, when you set up a GKE cluster, you set as a public cloud, which means your API server is remotely reachable, like what we just did. So we want to set it to the private cloud and then use something like a bastion host or like a jump host to then connect to the API server securely. Lastly, we want to always monitor our Kubernetes API server and use GKE audit logs to see if there's anything suspicious going on. Next, we're going to look into Tigera Secure and how we can use Tigera Secure or Calico to set up some basic network policies. Tigera Security just has basically a nice GUI for you to use to set up the network policies. So I can show it to you and see how it works. Actually, so before that, we can actually show you the flow logs that Tigera Secure also provides. While I was doing my demo, we can already see that we actually have different flows that was actually marked. We can see, for example, here, the screenshot app is talking to the shop app. You can see the screenshot app talk to the kubedns. We can see the view app talking to the shop app. And now you can see these two where the screenshot app is talking to the public, which means the external, like when we're reaching Google, for example. So with that in mind, we can now create some network policies. We're going to go to our Tigera Secure policy board. And this is where we can create a new policy. So the first policy we're going to add is just a very basic policy. We're going to try and block egress. So what we're going to block egress, what we want to do is we want to first set our scope to namespace. And since our screenshot app namespace is default, we're going to put it as default. Next, we want to set it so then we are applying specifically to just the screenshot app. So we set it as the app is equal to screenshot app. And then we just save. Next, we want to set it to block egress. So we're going to set it to type egress. And we're going to click add to egress rule. And first, what we want to do is we want to enable any connections with any protocols to the namespace, to any namespace. So this will then allow the screenshot app to talk to anything that's within our Kubernetes network. Next, we want to add another rule to deny everything else. So with that, we just need to apply on the right. And now we have a new network policies. So this GUI is actually just basically create the YAML file for you if you're using like Calico. So next, we're gonna go back to our command prompt and we're gonna now try to see if this actually works. So we're gonna do kubectl exec into our deployment. Screenshot app, and then we're going to curl Google. And we can see that we're not connecting, right? It's just continuous loading. To make sure this actually works, we can also try to hit our screenshot app. I mean, we can try to hit our shop app by accessing the shop surface, and then let's try going to site A. And we can see we actually got some replies, which is our site A reply. So we know we actually blocked the external or egress to external resources like Google, but we are still letting the connections within the pods and within the services that's inside your Kubernetes cluster. It still works. Lastly, we want to, of course, make sure that we can actually block the metadata.google.internal. And we can see it's very similar to google.com, it will never load, and eventually it will just time out. So we block egress. Next, we want to try to do another different method. First, I'm going to delete the policy. And now what we want to do is we want to create something called a network set. I've already set it up for you, but it's basically, you can see here, oops. We have a label called red, and then our IPs is just the 169.254.169, which is the Metadata Service API's IP address. And now that we have this network set, what we can do is then create a policy to block that specific network set. So I click add policy, and we're going to set it to block metadata. And here, we're going to set our scope to global. We want to apply it to just the screenshot app again. And then we're going to set it to only egress. And then we're going to add an egress policy. So the first policy we want to add is the deny to our network set. So we want to set a deny to all protocols. And then for our endpoint, we're going to pick the color, and then we're going to choose red. And then we save. And then we're going to add another egress rule, which allows everything else. So I applied it, and then now we can take a look at it again. So we can go back to try and see if we can reach the metadata.google.internal. I click enter, and it's loading, but we can see that it's not getting a reply. We can try the next one where we hit the shop surface, and we instantly get a response back, so our site still works. And lastly, we want to try hitting Google. And we can see a lot of text. This is the Google website. So now we specifically only block the metadata service. So back to the slides. So to recap, what we did on Tigera Secure, we saw the network flows between the different pods and surfaces using our Kibana service. We then used the network policy GUI to create a policy to block egress. And then we double checked it by exec into the screenshot app and then trying to reach Google and the metadata service. We then remove that policies and then add a new policy to just block the metadata service by using a network set. So in conclusion, today I demonstrate a possible attack scenario. We walk through the different points of the attack and discuss the different approaches to prevent them. I demonstrated how Tigera Secure and Calico can also be used to create network policies to reduce the attack surface. Although we couldn't do much with the credentials we talked today. In a future webinar, I will show you what we can actually do to pivot and get more access. Here are some references that I've found that I used to create this demo. You can always reach me at garwood@tigera.io. Oh, and that's basically it for me.
Yeah, thank you, Garwood. So while we wait for some questions to come in, I think we already have a couple. We only have a little bit of time, but just want to let everyone know about Calico Con 2019 if you are a Calico user or would like to be. We are actually having a one-day workshop, which we'll have a hosted environment, and you will be taught how to use Calico in several different scenarios. It's going to be a great day. It's co-located with KubeCon this year in San Diego, so it's on November 18th, which is a Monday. So if you go to tigera.io, you will see a pop-up for Calico Con, and you won't miss it, and you can go ahead and read all about it and register to attend. So I'd love to see you guys there. So we have a couple questions and about 4 minutes left. So Garwood, you want to take some of those questions?
Sure.
Okay. Looks like we have about 3 or so. So I guess the first question is referring to the screenshot app, and it asks, why did the XSS become SSRF? This is a little while ago, though. Hopefully everyone can remember.
Yeah, so basically, when we had our screenshot app, the screenshot app actually just acts like a browser. So in our case where we saw how, when I tried to do the redirect to the metadata.google, it doesn't really work on my laptop. But since screenshot app is still part of the cluster and it's in the pod, it's actually able to reach the metadata service. So our originally cross-site scripting or the redirect, it was client-side, but then since we're inside the cluster and pods, it's actually able to reach the internal APIs, and this means that we have a server-side request forgery tag instead.
Gotcha. I think this question is also in relation to the server-side request. It was asking about adding, can't you add headers using JavaScript as well?
Yeah, so like in my case, the website was very, very vulnerable, and we were able to add like a lot of JavaScript and stuff like that. In reality, a lot of times, the attacker can only control like the URL, so you wouldn't actually have access to that much control like what we have here. And in that case, then yes, you won't be able to create a header. But in my case, yes, I can actually add headers with JavaScript to actually add the Google metadata flavor Google header.
Okay. Let me see. I'm trying to distill this question down. I guess that what they're asking is about network sets. And can you explain a little more about what network sets are?
Sure. I will just show it back sorry, I'm going to present our screen share.
Yeah, go ahead.
I'm going to go back to the Tigera website. What the network set do is just essentially, if I create a new network set, you basically pull in like different IP address that you find interesting. So for our case, the metadata service. Sometimes you can also do like maybe there's some malicious or suspicious IP that you want to like include. And what this does is then we create a set that we can then label as suspicious, and then we can then set it to block like what we just did instead of just one specific IP. So you can do like a list of IPs or domains, then we can just be like label all of these and say, okay, these are all bad IPs. We're just going to directly block them all. Let me head back to the site. Yeah.
Okay, great. Well, I think that is all the time we have for. That was a full hour. So Garwood, thank you so much for your presentation. And we look forward to seeing more presentations on security vulnerabilities and how to protect yourself against them. Once again, thank you all for attending. And if you have any questions or would like a copy of the slides, please contact @tigera.io. And if you'd like any topics, webinar topics, we'd love to hear from you also to that same email address, and let us know what topics you'd like to hear about, especially since we're going to have Garwood on more, what kind of vulnerabilities you'd like to see looked at. So anyway, I thank you so much for attending, and we will see you at our next webinar. Thank you, and goodbye.
Thank you.